Yeah, welcome back to AWS DevOps Lokesh Tech YouTube channel. And today we are going to discuss about Kubernetes and network policies. So kindly share my channel, like, subscribe to. So if you like, I don't force anybody. It's your complete wish. Okay. Anyway, let's get into topic. Let me share my screen. One second. Yeah. Is it visible, Ishwan?
Yes, sir.
Yeah. So today we are going to discuss about network policies in Kubernetes. Okay. So we have been talking about this network since long time, right? Yeah, I've already emphasized many times network policies are very, very, very most important. You have to understand all these networks. Okay. So let us first get uh, into our networking and security basic. Okay. I just wanted to spend a minute on this. Make sure that we are all on the same page, right? So before we begin this, so we will start the sample example of traffic flowing through the web app. Okay, this is one second. Okay, this is, for example, this is web. Okay, this is API and this is storage. Okay, this is kind of structure. For example, in the network traffic, he is user. Okay, so you have a web server. For example, this is web server. You have a web server serving front end users. Okay, serving front end users and app server serving back end. Okay, front end app server to the back end. Okay, so API and database server, the user sends in the request to the web server at port 80. Okay, so he is user, is going is user is trying to access web server. Web server is connecting with the API with the 5000. Okay, API is connecting with the database, that is 3306. These are all ports. Okay, so 80 is for connecting the default. For example, so default, one second guys, I got a call. Okay, this default, okay, web server is 80 port. Okay, the web server that sends a request to the API server at 5000 in the backend. Okay, this is for backend. Okay, so in this case, API server then fetches data from the database server at port 3306. API, okay, from the database it fetches the data using the port is 3306 at port. Which port? 3306. Okay, a very simple setup this is actually. So there are two types of traffics here. Okay, so one second, I have to operate all these things. Okay, there are two types of networks traffics. Okay, one is ingress, the other one is egress. Ingress and egress. Okay, so for example, a web server, the incoming traffic from the user is ingress traffic. A web server is getting the traffic from the user, that is called as ingress. Okay, so next, the incoming traffic from the users is ingress, that is called as ingress traffic, and the outgoing request to the app server is egress. Guys, try to understand these two, ingress and egress. Okay, what is egress? The users is an users, whatever users is sending request, it is incoming from the incoming, getting incoming from the user, that is called as ingress. Okay, and the outgoing request to the app server is egress. Okay, so that is two differences. Incoming, getting incoming, that is ingress. Going outside, that is egress. These two terminologies are very most important. Kindly keep in your mind. Okay, so you are looking at the direction which is the traffic, okay, originated. You see here and here like this. Okay, and after that it is coming here and it is taking back, fetching the data, okay, from the database. The response back to the user denoted by the dotted lines. Getting back here, here it is taking back, and here getting like this, and you will get the output to the user. Got it? First two, you are sending request to the browser. The traffic, whatever the traffic is getting, that traffic is called as ingress. And going outside from the browser, okay, whatever going outside from the browser, that is called egress. And the same response, whatever we are sending, that in ingress to the, where it will get, it will store whatever the data is there, that data will fetch, and that data will go through API to the user, that is called outside. Okay, this is out response, last final response to the user. User will see what is the data is inside the database, that database he can able to see. Okay, so if we are list the rules required to get this working, we will have an ingress rule that is requested to the accept http traffic 80 port, okay, on the web server, this web server. And ingress rule to allow the traffic from the web server port is 5000. This one, what I'm trying to say is, ingress rule to allow the traffic from the web server port is 5000 on the API. Okay, so server and in an ingress rule access rule to traffic, accept the traffic on the port 5000 on the API server. Okay, so API server and add to the ingress as a rule to allow this rule. Okay, 3306, this is a port. With this port you can able to access the database. Okay, database server. Finally, an ingress rule on the database server accept the traffic with the port of 3306, so that database to do that stick traffic flow the rules. Okay, let us see here, network security in the Kubernetes. So we have a cluster that set of the nodes hosting a set of pods and services. So these are all comes to services, net ingress. So each node has an IP address. For every, each node has IP address. Let me see this. So I have given here clearly. Ingress port 80, egress port 5000. Okay. So next to with this 5000, it will enter into this database with the 3306 and 33 ingress and egress, incoming ingress, outgoing egress, whatever if it is there. Okay, first user is there, user comes to the web server. Okay, ingress, that is called as ingress to the web server, and egress to the API server. Okay, API server again ingress to the this database. Okay, did egress to the API, again egress to the from API to this web server. Whatever the output database is taking, whatever the database, that will display in this web server to the user. This is the process, this is the process will happen all these things. Okay, so for networking in Kubernetes is, whatever situation you implement, the pods should be able to communicate with each other without having configure any additional settings like routes. For example, in this network solution, all pods are on the virtual private network, okay, across the nodes in the Kubernetes cluster. Okay, by default each other using IP or pod names services configured that purpose. Okay, so network security, I hope you could not able to see this. Can you able to see this? So network is connected, for example, if it is this node 1, I will try to explain this only. This is node 1, for example, node 1, this is IP. Okay, node 2, okay, this is node 3. So we have 3 nodes, correct? Right, so every node has
Yes, sir.
the IP address, correct? So with this, how network is established, this every node have IP, separate 3 nodes we have, these 3 nodes is 3 nodes. So these are all pods, pod 1, pod 2, pod 3, pod 4, like for this node, pod 1, pod 2, pod 1, pod 2, pod 1, pod 2, like this. And it is network is establishing like this, it is connecting, interlinking with this. Okay, I don't know the picture is proper or not, I'm not sure. So I have taken it just it as example. So what I'm trying to say is Kubernetes, in the Kubernetes, whatever the solution you implement, the pod should be able to communicate with each other. So like this, pods will communicate each other, all pods. Okay, so this will connect to this will connect this big network. Okay, so all pods will communicate with each other without without having to configure any additional settings like routes, something. Okay, or in the network solution, for all pods are virtual private network, will be there. So by default IP address, pod names will be there, services will be there, pod names, services. Okay, using IP. Okay, so this, so Kubernetes is configured by the default with all allowed rules that allows traffic from any pod to any other pod, traffic from any pod to any other pod. Okay, so it is completely linked. Okay, so any other pod, so services also within the cluster, let us know. So I think we have discussed earlier, so how to fit into Kubernetes. Let me try to do this. So for each component in the application we deploy a pod. Okay, for each component in the application we deploy a pod, one for the front end and front end web server. Okay, one for front end web server, for example I will use this here. Okay, this is web server, this is for front end. Okay, front end web server, for, this is API. Okay, API, this is one pod, this is another pod, this is another pod. Okay, so and the other pod is for this database. We create services to enable the communication between the pods as well as end user based on what we have discussed previous one. I can't move, I have to again. So here, see, so based on this picture you can try to understand. If I move this again, so it'll change. Okay, anyways, so yeah, for each component of the application, so we deploy a pod. One pod is for front end I have given, one pod is for back end, one pod is for API, right? And as well as end user based on that um, default, I think so. Yeah, one three pods. Yeah, pod one, pod two, pod three, three pods, right? So what if we do not want to front end web server to be able to communicate with the database server directly? Let's say, for example, your security audits required you to prevent that. Just like pods, replica sets, or services, you link a network policy to the to one or more pods. Okay, like this pod will communicate with this, and this pod will communicate, this pod will communicate, right? So replica sets or services, you link network policy one or more pods, like this. So you can define rules within the policy, network policy. You can define the rules within the network policy. In this case, I would say only allow ingress traffic from the API pod on 3306, ingress to the this database. What, how much? 3306. So once this policy is created, it blocks all other traffic to the pod and only allows traffic that matches the specified rule. Okay, once this policy is created, so it blocks all other traffic to the pod. Okay, so again, this is only applicable to the pod on which the network policy is applied. Okay, how do you apply or link the network policy for a pod? We use the same technique that was used to like link replica sets and services, pods, labels, and selectors. Okay, and so we labeled the pod and use the same labels on the port selector field, the network policy. Correct. We have seen that while we are creating a lot of pods, so how we have to use the labels. So at that same way we have to use the policies. Then we build the rule under the policy type, specify whether we rule is allow ingress or egress traffic, or so I'll show you then. See, like this. So for example, in this also, if you see, so API version, kind, metadata, namespace, these are all common. In the pod selector, match labels. Okay, role is DB, policy type ingress. See this, policy type ingress. So like this we have to give. Okay, so yeah, so how labels network policy selectors. If it is a DB pod name will be there, right? Network policy, we will create a one policy for the DB, correct? Pod selector, match labels, role is for DB, labels, role we have given for DB. So we have to specify, bifurcate, and we have to specify clearly, we have to denote it like this. Okay, try to understand while we are doing practical, you can understand clearly. Okay, so mm, so here if you see, we start with the blank objection definition. So API version networking Kubernetes so and so version 1 we are mentioning. The kind is network policy. We will name the policy. Okay, we will name it to the policy DB dash policy, right? This is the name. Okay, DB dash policy. And under the specific spec section, we will first move the pod selector to apply this policy to the DP pod. Okay, pod selector, match labels, role, so DB. Then we will move to the rule we created in the previous slide. So not created, I have shown you, right? And that's a, we have our first network policy I have shown. So now, mm, so while we are mentioning ingress and egress isolation, only it comes into the effect if you have ingress or egress in the policy types. In this example, there is only ingress policy type. So which means only ingress traffic is isolated and all egress traffic will be unaffected, meaning the pod is able to make any ingress calls, they are unplugged. Okay, if you are mentioning in the sense you are allowing ingress. Okay, so for an egress or ingress isolation to take place, so note that you have to add them under the policy types, otherwise there is no isolation. Okay, so we have to run the we have to add all these things, man. You try to understand with the previous whatever slide I have shown. So we are mentioning here API version, kind, network policy, metadata, name we are mentioning like db policy, spec specifications what we are mentioning, pod selector, match labels, role is for database. We are mentioning only for database. This policy type, what is the type? Ingress. That's what I'm trying to say, man. This ingress. Okay, no egress, right? So we are allowing ingress from pod selector, match labels, role is API hyphen pod. Okay, selectors, ports what we are opening, TCP IP port are 3306. Okay, this is database port only, right? So
Yes, sir.
we can write network policy, we can create the network policy in pod. For pod we can write network policy like this, we can write the manifest file. Okay, we can create a policy definition file like this. Okay, so this is how we can create API version, kind, metadata, something like this. The same if you write like this you'll get. Okay, so this is how. So we'll do while doing practical we can try with this all these comments. Okay, so these are all examples I have taken from the chat GPT. Okay, so one two I have taken a lot of examples. These are all for the practice. Understood?
Yes, sir.
So our goal is to protect the database pod so that it does not allow access from any other pod except API pod and only port 3306. So let's assume that we are not concentrated like we are about web pod or API pod. For those pods we are okay for all traffic go and out from anywhere. However, we want to protect database pod and only allow traffic from the API pod. Okay, so we don't need worry about the web pod, its port, because the port is 80, that is default port. So we don't want to allow any traffic from any other sources other than API pod. So just let's get right into that. So we can just also forget about the port of API pod which web server connects. Okay, like better I need to show with it this. Okay, so as we don't care about that earlier, so we just discussed by default Kubernetes allows traffic from all the pods, all destinations. So as the first step, as we want to block out everything going in and out of database pod. So we can create network policy first. Okay, we will call it db policy, and the first step is to associate a network policy with the pod that we want to protect. And we do that using labels and selectors. So we just we do that by adding the pod selector field, and with the match labels options, like database something I've shown in this. There are a lot of examples I have shown actually in this. So we need to add API pod able to query, like a database port is 3306. That's what we are going to configure next. First we need to configure, and we need to figure it out what type of policy should be defined on the network policy object to meet our requirements. So there are two types of policies, as I already previously mentioned. One is Ingress and the other one is Egress. What is Ingress? Ingress is for incoming the
Incoming
traffic,
data, sir.
incoming traffic, and Egress outgoing
Outgoing.
from the browser. For example, if you take a browser here, so Ingress is you are giving to the traffic to the web server. Whatever you are giving to the traffic web server by using port 80, that is Ingress. And going out, whatever releasing it to API, it is connecting to API, right? That whatever it is releasing outside, that is called as Ingress. Okay, sorry, Egress. So again, whatever Egress is, whatever output is that, that output is input to the API, that is Ingress to the API. And API is also connecting with the database, right? That database is taking call from API call to the database, that is called as Ingress to the database. I hope I'm trying to reaching you out, guys. I'm not sure whether your people are understood or not. Again I try. So this is example user Yashwant. Okay, Yashwant trying to access this web server. Okay, this web server, whatever, maybe he hitted something, for example www.xyz.com. For example, if it is this, he hit something, which means Yashwant given the input to the web server, right? That web server with the port is 80, whatever you have given, that is Ingress. Okay, you are connecting with this web server, whatever traffic you have given, that traffic is called as Ingress. And whatever it is releasing it to, which means you hit something, that if you hit something, that will connect with this API will take it from the database, and again this process should be run like this, right? Like this, correct?
Yes, sir.
So which means here, whatever it is output is there, that is whatever output is coming, whatever output is from web server, that is Egress. Okay, and this output is become Ingress to API server. Okay, whatever the port, this Ingress with the 5000 port, and API is connecting with the database. Okay, this database is, okay, it is connecting with the database, which is Ingress again. Ingress to the, see, this is Ingress to the, whatever output is coming from the web server, that is Ingress to the API, and the output is Egress to the database. So which means incoming, whatever incoming is, that is Ingress. That's what I'm trying to say. Output is Egress.
If
Egress. For example, if it is web server incoming traffic is Ingress, outgoing is Egress. Same way. So here user is hitting that hitting the traffic is getting, that is Ingress. Outgoing is Egress, and this Egress will become the Ingress for the API, correct? right? So this API, whatever API is that is connecting with the database, that is ingress. Okay, again if it is giving back to the API, that API through it will get the response through this to the user. So this process, whatever incoming, whatever we are trying to say, that incoming is ingress, outgoing is egress. That's it. Simple. This terminology, to understand the terminology, I have explained all this stuff. Okay.
Yes, sir.
So if you see more examples,
Sir, Yogesh has just messaged me he's in the lobby. It seems.
sorry,
Yogesh just messaged me he's in lobby. It seems unable to join for the class.
why?
I think you have to allow. He's in lobby.
Okay,
It seems. If
okay,
you think.
okay. Why I have allowed him, right?
Yeah, but I think he disconnected.
Yogesh, you disconnected. Hello, hello. Can you hear me, Yogesh? What happened to him?
Yes, sir. Yes, sir.
So why
Some
disconnected?
my system,
How, how
sir,
long
my
you?
system is getting automatically restarted, sir, every time.
Okay, how long it's been? How long you back disconnected? How much
Like
time?
Egress, sir.
So you understood,
I
right?
understood
Ingress,
that
egress.
topic.
Okay, that's fine.
Yeah, yeah,
So incoming is ingress, outgoing is egress. Maybe egress will become the ingress
yeah.
with some other, right? You understood this, right?
Yes, sir. Yes, sir.
So user might be there. This, okay, one second. I'm sorry. So I should not use this. I'll use this. So this terminology is important. That's why I'm telling. Maybe there are chances to confuse by others. That's why I'm trying to focus. This is the person is giving. This person is using web server, for example, using port is 80. So whatever network is traffic is there, that traffic is came to the came from the user. Okay, that incoming is called ingress. Okay, that is to ingress to the with the 80 port. Okay, again from this API. Okay, this outgoing, whatever output came from the browser, that is egress. Okay, this egress becomes the ingress again to the API. You understood? Okay, this ingress
Yes, sir.
came again, this output, whatever output came, that is egress. Okay, this input, whatever input is coming, that is ingress to the database. You understood? This whatever output is coming to this API, that is egress. You understood? And again API, for API something is getting, output is egress. Again this egress becomes to the ingress to the API. Through this API, again egress will get and ingress will get, right? Ingress. So this is whatever output is ingress, and this response to the user. This is the process. Okay, I hope you
Yes,
understood,
sir.
guys, right?
Yes.
So
Yes, sir.
I have taken a lot of examples from the chat gpt. Okay, let's try with the practical. So these are all different types I have taken from the chat gpt, because chat gpt can give a lot of best examples. So that's why I have used chat gpt. See this. This is for the database access using ingress, right? So network policy created, database access, this is for database access, namespace default. Okay, selectors mentioned, labels mentioned, policy type ingress. Okay, ingress in the sense you are giving this as input to the database, which is ingress. Correct. Ingress, if something is mentioned, ingress means that is something to income to the something. Okay. Okay, so port is 54332. So like this. See here, network API version, kind, metadata, namespace, something namespace if you want. can keep your namespaces also. Specifications you mentioned pod selector, okay, policy type ingress, okay, here also given egress, both incoming and outgoing, both, okay. So like this. So shall we continue? So is that cluster ready, Ishwant? So let us do some at least one example, two, three, four examples like that. uh,
Yes, sir.
so is that cluster ready? I hope you
I
can
have
hear
given
me.
for the validation, sir. Yeah, I've given for the validation, sir.
Okay. So this network policies, this not that much big theory in this actually. So I try to repeat multiple times to understand this terminologies properly. So let us do this examples. First example is, I have some examples in this. So when we have started,
It's been 1 hour, sir.
okay. So you can share your screen also. I'm going to close this. You can share your screen once a cluster ready.